Hello. Today we're going to look at distance formula. So make sure you've got 1.3 day 2 for your notes. And then go ahead and grab, yesterday we worked on midpoint formula, grab that foldable. We're going to look at distance formula, but yesterday we talked midpoint. So you might pause it if you don't have these two items out. So I want to go through distance formula real quick. We're going to switch over to the notes packet and run through some examples, and we're actually going to start a little bit with midpoint and then switch over to distance. I do want to start with the foldable though. This is possibly a formula you've worked with before. It's similar to midpoint in that it deals with coordinates. So see how I have like x1, y1, I've got x2 and y2. Same thing on midpoint. So distance formula is used when we're on a coordinate plane. And so it finds the distance between 2 points. Okay, so this is the formula, and it looks kind of hard, but it's not too difficult once you get the hang of it. All right, so let's turn to the inside here. So I want to start on the left here and relate it to the graph. So the distance formula is used to find the distance between 2 points on a coordinate plane. So if you were provided this ordered pair and this ordered pair, and you were to substitute in and calculate, you would find the middle point. Nope, back up, not the middle point, sorry, I was thinking midpoint. If you ran it through the midpoint formula, you'd find the middle point. But the distance then will find the distance between the 2 points, or it would give you the length of the segment. I'm gonna add in here too, length of segment. Because sometimes you're asked to find the length of segment AB. And if AB is on a coordinate plane, then most likely you're going to plug into distance formula. So let's just go through plugging in and using this formula for these two examples. I would recommend, if this is your first go around with distance formula, let's label points. So I'm just going to call this first point x1, y1. And it doesn't matter which one you start with or not. You can switch these. x2, y2. All right, so I'm going to plug in parentheses, x2 minus x1. So I often think of the second one minus the first one. So I've got 2 minus negative 3. And I would recommend at first you do this, 2 minus negative 3 squared, because it's really easy to skip that second negative, because in a minute we're going to turn around and call that 2 plus 3. Formula has a plus sign in it, and then y2 minus y1 squared. So I have 3 minus 1. So parentheses 3 minus 1 squared. So I'm going to take it little by little. I'm going to evaluate the parentheses next. So I've got 2 plus 3. So now I'm going to come through here and go like this, just to re-emphasize that that's really going to be a 5. And then 3 minus 1 is 2. Now I'll square both numbers. So I've got 25 plus 4. I'll work this way. 25 plus 4 is 29. Depending on directions, we could type it into our calculator, round it to the nearest tenth. If I needed to do a simplified radical, I would stop here. Let's go ahead just for this foldable. Let's use our calculator. So if we did square root of 29, so that's approximately 5.4. So I'm just going to add that here. Approximately 5.4. Okay? So those are the mechanics of the formula. Go ahead and do the second one, and then come back and we'll check the answer. Okay, I'm just doing the same thing. Second one minus first, second one minus first. If you switched it around and did negative 2 minus 2 and then 1 minus 5, we're going to get the same answer in the end, so it doesn't matter. Okay, so we got square root of 32. So let's go ahead and simplify this radical just to get a little bit of practice with that. So 32, I'm looking for a perfect square and a non-perfect square, and I really want the largest perfect square. So if I think about doing like, if I do 32 divided by 2, that gives me 16. Okay, 16 is a pretty big perfect square, so I feel like this is going to be my best bet because 2 is a very small number and it will not simplify further. So I'm going to simplify into square root of 16 times square root of 2. And then 16 is the perfect square, so that will give me 4 square root of 2. So if we left it in radical form, that would be simplified radical form. Of course, we could do a decimal here as well. Okay, so that's distance formula. We can run it through formula. It finds the distance between 2 points, which then will also give you the length of the segment. Okay, I'm going to pause this video or stop this video and then come back with the examples.